So this is the explanation of the formation of the tropical storm. So diagram looks quite complicated. Don't be thrown by that. It's a very kind of specific cloud formation. So what have we got? Bottom we've got the ocean. So warm sea surface temperature has to be more than 26 degrees. The location will be more than 5 degrees north or south of the equator, so the warm part of the sea. So the very first thing that happens is basically the ocean is so warm that the air rises. So that's what all these arrows are for. I'll take you through the formation in a little bit with the sequence, but let me just point out what's happening on here. Rain and thunderstorms here. The greatest amount of rain is here and here. So what this is each side of the eye. So the cloud is this spectacular shape called a Cumulonimbus Cloud. And at the very centre, this eye, there is no cloud whatsoever. So no wind, no cloud, no rain. But the worst weather is each side of the eye. Strangely enough, in the eye, actually within the eye, the air descends, which is those two green arrows. Basically because it's each side of it, it's spinning. So this spinning here is representing the whole of the tropical storm. It's actually spinning up in the middle and then rotating as a whole thing. It looks like I'm doing that in a different way, but I'm not, because as that spins, it rotates there. Cumulonimbus Cloud, I've told you that already. The rotation of the Earth actually makes this cloud spin because this storm is so big, it gets affected by the rotation of the Earth. This height here is about 15 to 20 kilometres above the ocean. And then the storm is moving from right to left. So let's go through the processes. So on the slide on the PowerPoint, you've got these, there's seven sequences of how the storm actually occurs. So the first one, intense heat around the equator of the sea temperature here leads to evaporation of the warm seas. So this air contains a huge amount of moisture and gives energy fuel to the storm. So basically what this does, it actually creates the cloud. You know about how cloud forms from the water cycle stuff, but the air rises, cools, condensates and forms the cloud. So you've got a very uniform airflow upwards, and that's really important because you've got a huge amount of cloud here. You also need a uniform direction moving the storm in one way as well. The warm air, as it rises, this is number 3 now, is replaced by warm air from the ocean. So it's continuous. That's why the cloud gets so big. And as the storm travels this way across the ocean, more air is drawn upwards, cools, condensates and forms these towering cumulonimbus clouds. So that was point number 4. Number 5, the condensation actually creates its own heat. It creates latent heat, which powers the storm even more, which creates more heat, so you get even more evaporation and even bigger. As I said already, the cloud grows so large that it's affected by the spinning of the Earth, the Coriolis force, so it all spins around this central eye. If that storm, though, moves over the land, this is the last point, number 7, the supply of energy gets cut off because the moisture's cut off. So you replace this sea here with land, and there isn't as much moisture that's going to be rising. So the fuel gets cut off. The storm will start to decay. And in the Saffir-Simpson scale, it will go down to number 1, probably even not be a hurricane anymore and go down to being a tropical storm. But if it then moves back over the ocean, which is very, very common, there's your fuel again, the moisture from the ocean, and it will become invigorated again and possibly even build up and become a bigger storm.